Hey, welcome to the third and final video describing some features of the Demo20sim 3D animation window. Again, we're looking at this single pendulum which oscillates in the XY plane, has a total length of 1 meter, and pinpoint A, center of gravity G, rotation angle of theta. We've previously animated it with a line and with a rectangle, and when we brought in the rectangle, we scaled it so that the body fixed frame had the rotating X direction along the long axis of the rectangle that represented the pendulum. I'm now going to do this by bringing in a cylinder instead of a rectangle. So if I double click on 3D animation, and if I highlight reference frame and right click, actually I'll just right click, insert, cylinder. I'll place the origin at the center. I'm going to scale it. Now when a cylinder comes in, it has a body fixed axis set, but the z-axis is pointing in the long direction of the cylinder. So I'm going to make the cylinder thin about the x and y axes and make it 1 meter long in the z direction. I'm going to make it orange, and if I choose material, I can vary the transparency of this particular cylinder, and under cylinder properties I can show the inside and the outside, so maybe I can see my line at the same time as my cylinder. I'm going to set the position of the cylinder to be inertial x and y, which are the integrals of the inertial velocity components of the center of gravity. Oops, yg gives me the y coordinate. Now for orientation, if I choose the same rotation matrix that I chose for the rectangle, which had its body fixed x-axis in the long direction, instead of body fixed z, let's see what happens. Okay, so here is my cylinder. If I just press left click and then move around on my touchpad, I can get an isometric view of this thing. I'll run the simulation, and then I'll play the animation. So I'll actually do that again. Okay, Demo20sim seems to have frozen on me here. Alright, here we go. So now we're playing the line animation, and as we can see, the cylinder isn't doing what it's supposed to. It's not oriented the right way. So what's going on? Alright, let's take a look back at our little PDF chalkboard document here. So I'll flip the tablet PC around. When we bring in the cylinder, okay, it's coming into the inertial frame. So let's see, we had y that way, x that way, and z coming out. Here's the way the cylinder comes in, and it has a body fixed frame that has a z that way. I'll put the origin at the center, so I'll draw the origin at the center there. Okay, we have x, we have body fixed y, and we have body fixed z. So I'm going to call that frame 1. Now the first thing I need to do is I need to get this body rotated so that the cylinder ends up pointing along the x direction, and then I'll have it rotate through its angle theta. Okay, so once I rotate that cylinder by 90 degrees, let's say its center of gravity is there, it's going to have its body fixed z direction that way, it's going to have its body fixed x direction that way, and it's still going to have its body fixed y direction pointing upward. Okay, so I'm going to call that frame 2. And if this is point A, and if that's point G, okay, now the coordinate systems are looking a little bit messy here, but originally, if I'm looking at the vector from A to G, position of G relative to A in frame 1, that was just A, that was 0, 0, AG. It was all along the body fixed Z direction. So the first thing I want to do is I want to rotate this so that AG lies along the x-axis. So RG with respect to A in frame 2 should be AG 0, 0. So I'm going to use a rotation matrix to do that. So I need AG 0, 0 to be the result of some rotation multiplied by my original vector in its body fixed frame, which was 0, 0, AG. Now a rotation matrix, if I go back and look at the definition of a rotation matrix from before, this was a rotation matrix from rotating frame to stationary frame. This column was the components of rotating I in fixed I. So similarly, this first column should be the components of the I vector in the inertial frame. So the I vector is now pointing in the negative Z direction. So the body fixed I vector is now 0, 0, minus 1. It's in the minus inertial Z direction. Body fixed Y is still pointing straight up. Body fixed Z, a unit vector that way, is now 1, 0, 0. Okay, so now I have this cylinder aligned in what I'll call frame 2. Next, it's going to go through an angle theta. Okay, so now the body fixed frame is going to be Z, X pointing back into the page, and Y at some other angle. So I need to get from this vector, which is this rotation matrix times my original body fixed vector, I need to get from AG in the rotated pendulum, I need to get the inertial coordinates of that. Okay, which should be AG cos theta I plus sine theta j. So what I need to do, the correct rotation matrix is going to give me position of G relative to A in frame 0. I'm going to use the same rotation matrix I used in the last example, which takes me from rotated in the xy plane down to inertial xy. 0, 0, 0, 0. And I'm going to apply that to my original cylinder rotated 90 degrees. 0, 0, 1, 0, 1, 0, minus 1, 0, 0, times RG with respect to A in the original frame 1. So this is my new rotation matrix, which I will just call R. Now if I go back to 20sim, and if I go back to my pendulum submodel, in the theta integrator block, I have my original R01, and I'm going to define a new variable R. So I'll flip my tablet PC around so I've got my keyboard. Okay, I'm going to define another matrix variable R. Again, 3 by 3. The new rotation matrix is going to be cos minus sine 0, sine cos 0, 0, 0, 1. And I'm going to multiply that by 0, 0, 1, 0, 1, 0, minus 1, 0, 0. Alright, and now I'm going to start the simulator. I'm going to go to my 3D animation window. I'm going to double click on 3D animation, highlight cylinder, and now under orientation I'm going to choose the new rotation matrix I just defined, and I'm going to click OK, and I'm going to run the simulation. And lo and behold, I do get the pendulum oriented in the correct direction, as you can see. So the pendulum and the line are doing the same thing. Okay, so that's good news. And the final thing I'll do, I'll stop the simulation, and I'll just show you the frame of the cylinder. So under cylinder here, I'll go down and click show frame. Okay, and now in the 3D animation window, if I control click and zoom out a little bit, you can see that the body fixed frame for the cylinder has Z shooting out in the longitudinal direction. So the transformation was a little bit more complicated than before, but we've seen how to do it. Okay, that's it. Thanks again for watching.